Alright, in our first little video, we learned that if we multiplied r by theta, then we got d. That's giving you an arc length measurement is the actual angle. So it's kind of like this. If we've got a certain theta and we've got a certain r, if I want that measurement, then I just go r times theta gives me that distance here. So this distance here is d, r is the radius, and theta is the angle. Of course, that could be 100 radians, it could be 2 pi radians, would be one circle. So the radians are the angle, r is the radius, and d is that. Now, what about angular velocity? We're looking at angular velocity. We're asking ourselves how many radians in how much time. So we've got a new symbol. Omega equals delta theta over delta t. Okay? And that's what our omega is. But there's an interesting thing. We just said theta here, we go back to that, theta is equal to d over r. So we could say that omega is equal to delta d over r divided by t, delta t. The r is a constant, right? So that's just saying that omega d over t is our normal symbol for velocity, is v over r equals omega. And that gives us our second main formula. This one was our first. Our second formula is this one, which basically says omega times r equals v, or v equals omega r. We also said d equals theta r. Notice we just had the same formula that we had for linear velocity. We just multiply it by r, and we're going to see this pattern with all this rotational and angular stuff. You just multiply r by the angular one to get back to the linear one. So when you're going round in a circle, you're doing a certain number of radians a second. That's your angular velocity, omega. But what's the linear velocity? Well, that depends how big your radius is. If I've got a disk and it's doing a certain number of radians per second, the actual velocity on the edge of the disk depends on the radius. So v equals r omega. If you've got a small r, you've got a small v. But omega stays constant for a disk that's rotating. No matter how far out you went, even if this disk was huge and it was rotating, it's still going through the same number of degrees a second, which is omega. But the velocity for a point on the edge is much bigger if the radius is bigger. So that's angular velocity. What about angular acceleration? Now, angular acceleration is delta omega over delta t. Right? Now we're going to do the same thing we just did, which was we said, but omega, all right, omega, we already said here is equal to v over r. Okay, so if we do that one, we'll bring it down here where you can see it. We said that v equals r omega. So omega equals v over r. So if we actually substitute there, instead of our omega we've got delta v over r delta t, then we can see that that whole thing just equals acceleration over r is equal to alpha. So we've got our third formula here, which is just saying alpha r is equal to acceleration. So this is linear acceleration, that's angular acceleration, and you just multiply the radius. Same thing we do, we just multiply the angular one by the radius to get the linear one.